Ladies and gentlemen, welcome to the Quiroz Math YouTube channel for some of you, and welcome to the IBAISL guide for 2025. Now, I've been meaning to create a video like this one since a long time ago, and I used to have a video that was like top 9 or 10 tips or tricks you can do for facing your IB math exams, And although it was good to have those tips and tricks, and although those tips and tricks still work, I feel like I have learned a lot and evolved as a person, as a mathematician, as a YouTuber, and I have a lot more experience specifically with IBAISL compared to before. And so now I feel like I've reached the level where I can understand the structure of the test in a deeper level. And whenever I do this, I teach this as a tutor or in my videos or whatever, I find myself thinking in that structure, thinking in that procedure, thinking in that ideal approach. And so the purpose of this video is to try to explain that ideal approach. If I jump into each and every single key concept in a detailed level, this video would be extremely long, and that's not really what I want to do. So what I think I'm going to do is that I'm going to take so from May 2024, I'm going to take paper 1 and paper 2, okay, May 2024. So this is May 2024, paper 1, while this is May 2024, paper 2. And I'm also going to take the formula booklet, okay, and I'm going to explain this sort of structural approach, the key concepts that I feel like you have to know, okay, in order to solve these exercises, okay? So I'm gonna have these PDFs, written with a bunch of stuff alongside the mark schemes, okay? It's gonna have a bunch of stuff written on them. So I'm gonna be saving those PDFs, and I'm also gonna be writing down the key concepts into each of these sort of post-it notes or whatever I find relevant. And after I have all of those, I'm gonna go ahead, click export, and upload that to the Discord. Okay, we do have a Discord in this channel, the Quiroz Math Discord. Welcome, here it is. And one of these channels called Best Material, I'm going to be putting those PDFs here. Okay, so the purpose of this video is basically I will explain to you the structural approach I suggest for taking this test and any key concepts that go arising. Anything that we sort of write down in these PDFs, you can download yourself later. Okay, so part of the purpose is that this hopefully feels like a conversation. Probably not like a podcast, but hey, I'm putting music for you. I got a couple of PDFs ready for you. Get comfortable. It's gonna be a little while of living and learning. Here we are. So, that being said, enough blah blah. Let's jump into it. What is this structural thing that I'm trying to explain to you, or what is the big thing that I can share with you? So, the ideal approach, which is what I suggest. So actually, I guess some other teachers would disagree maybe, so I'm just going to call it the Quiroz Math approach. The Quiroz Math approach is the following. Basically, the first thing you have to do when facing any exercise is identify key concepts or buzzwords, okay? And when I talk about buzzwords, I'm talking about, something that you read and you immediately think, okay, I should probably be doing this or that. So just to give an example, we will jump into this later, but maybe, I don't know, here you can read, calculate the chi-squared value. So the moment you read chi-squared value, that could be something like a key concept or a buzzword, right? And so once you identify that key concept or buzzword, the next step is associating that to a procedure or formula. Okay, and more often than not, you're gonna end up in the formula booklet. And then the last thing you're gonna end up doing, of course, is execute that procedure. I guess the step before that is, do you have everything for that procedure or formula? And once you have everything for that procedure or formula, you can go ahead and, of course, execute that procedure or really just execute. Go ahead and solve. See? So this last thing, we're actually going to call it go ahead and solve. So what's the main idea I'm trying to share with you? If you learn deeply the key concepts and the buzzwords, okay, and you get familiar enough with them, you will be able to jump from key concepts to procedures and formulas. And a lot of these procedures and formulas are within your formula booklet. I would even say that, like, if you learn all these procedures and formulas, you're probably gonna end up with, I don't know, like 60 or 70% of the entire test is just you being familiar with the formula booklet and the key concepts and buzzwords, right? The next step is, of course, asking yourself, do you have everything to be able to use that procedure or formula? So maybe you do have to get creative, do this or that. And then once you have everything you need in order to use that procedure or formula, just go ahead and solve, okay? Why is this the Quiroz math approach? Because far too often I see people that read something that looks absolutely crazy, like this exercise. See, so number 10. Number 10 is crazy on this, by the way. It's worth 7 marks, and all it says is you have the gradient of the normal to the curve at the point T, and that gradient is negative 1/3. Find A and B. And so almost everyone that reads this, they're just like, okay, I'm gonna skip to the next one. Like, that's crazy. See? Once you train what I call the Quiroz math approach, okay, just to put a name to it, I guess. Step 1, identify key concepts and buzzwords. So the key concepts here would be gradient. So that's, well, understanding gradient, which is associated to this, the negative 1/3, and also keeping in mind what the heck normal means. That's pretty much it. If you understand those two things, because this gradient is associated to negative 1/3, if you understand gradient and normal, like, you're good to go, pretty much. There's 2 or 3 other things you need to do, but going from here to the procedure is the big step, okay? And so notice, going from identifying the key concepts to reaching a procedure, okay, is exactly what sort of like gets you the most points, okay? And this is the next thing I wanted to talk about, which I'm actually gonna write over here. Method points are a thing. Method points are a thing. Look at the mark scheme. So for example, it's number 10. See, let's go to number 10. And this happens all along the test, but there's a bunch of weird letters on the right side. See? A1, M1, A1, M1, A1, A1. Like, what the heck even is this? Okay? A1 is associated to, like, your answer. So notice, this A1, you get 1 point in this exercise if at some point you express 3. Quite literally. And in this context, it is expressing the slope of 3. Okay, I'm not going to jump into it, but just so that you get the idea, an answer point is literally like your answer, like the actual value. Meanwhile, there's method points here. And so this method point here, notice, has everything to do with doing the right approach. Look, award a method point for attempting to find the derivative. So just doing the attempt, just trying, just whoever's grading you, if they can tell you we're trying to get the derivative, you get a method point. Look at that. Method points are a thing. And so once you establish this approach that I'm telling you, which is identify the key concepts and buzzwords, associate this to a procedure, and like try the procedure, you're gonna get method points. And so notice, this exercise, you can get everything wrong. Let's say you get no answer points. So you don't get this one, you don't get this one, you don't get these 2. So you missed out on 1, 2, 3, 4 points, but hey, you got 1, 2, 3 method points. And so here, I mean, yeah, you didn't get 7 out of 7, but you got 3 out of 7 only with method. And that is extremely important. That is why the Quiroz math approach focuses a lot on mastering the key concepts and buzzwords, which allow you to reach this so-called... I just lost control of my... what's happening here. There we go. Let me reset. Having the key concepts and buzzwords and associating that to the procedures will get you method points. Method points are a thing. Very, very important. Okay, so associating these key concepts to establish which procedure to use, and always knowing which procedure to use with which exercise will net you all the method points. And look at that, 3 out of 7 only with method points. Okay, and if you're using the correct method, you're probably gonna get the right answer. So on average, if you know the method perfectly, this probably gives you 5 out of 7 or 6 out of 7, probably. Okay, and I can say this about almost any exercise, just randomly. Let's go to whatever, number 8. So number 8A, okay, number 8A, check it out, is worth 2 points. And so just for having the right method, you get half of the points. For the right method, you already get half of the points. It's crazy. And so, well, I'm not about to do the math on the whole test, but it goes to show if you get the right method, you're gonna get like 40% or half of it correct. And if you know the method, you're probably gonna get a couple answers right anyways. And so yeah, like you're definitely gonna get at least a 4. That's what I'm trying to tell you. You master this, you get at least a 4. And notice, you might be saying, oh, a 4 is not enough. Well, yeah, I'm telling you, you get at least a 4 with mastering the procedures. So if you master the procedures, it's at least a 4. And notice, this is assuming you're getting everything wrong. So wrong answers, correct procedure, you get at least a 4. Half of the answers right, correct procedure, that's probably like a 5 or a 6, dude. I'm not even kidding, okay? So master the procedures. The purpose of this video is to teach you those procedures, okay? Now again, I'm not gonna jump into every single key concept or buzzword because it is far too many, and that is why my videos are out there in the first place. So what I'm gonna do is that whenever I write down a concept that you should know, okay, I'm gonna put in the description of the video. I am going to put in the description of the video which of my videos I think is best for understanding that specific key concept or idea, okay? I will explain it generally, or at least point out the concepts you should know, and then you can click on my specific videos and discover those key concepts on your own. Now I know you might be thinking, okay, but you have like so many videos and it's so much time, I can't do that immediately. Well, my videos have timestamps, okay? I'm actually gonna write that here, that's another step. I mean, if you're in my channel, I suggest you use my stuff. So the other tip I can give you is that my videos have timestamps. So use the timestamps to learn the specific key concepts, okay? So just as an example, let's say you are trying to really learn, I don't know. Here, you're trying to learn expected value. And this number 6 has expected value right there. Okay? Now, of course, you don't want to click on my video and watch part A, part I, part double I, and plus introduction at the beginning, because that's already a lot of time. Use my timestamp, okay, and skip to part B. And once you skip to part B, you can learn that expected value on your own. It's probably going to be in the description, and I always put timestamps to make it easier for you, okay? So, any key concept you need to know, I'll have what I think is my best video explaining it in the description. You can click on it, use a timestamp to reach and learn what you need to reach and learn, okay? Okay, yeah. Let's jump into it. So, what are the key concepts and buzzwords and procedures and formulas that we have to establish? I mentioned earlier that around 60 or 70% of it is just in the formula booklet. So let's start in the formula booklet. Let's review the entire formula booklet. And if there's anything within the formula book, if there's anything that is not in the formula booklet that I feel like you should really know, I'm going to show it in the paper 1, paper 2 specifically. Okay? So, that being said, formula booklet. Why is the formula booklet so important? The formula booklet is so important because formula booklet, it is one of the tools you will have the day of the test. The day of the test, you're going to be walking in with a couple of things. Okay, you're going to be walking in with, you know, a pen, a pencil, an eraser, 2 years of experience of this thing called a B, 2 hours of sleep, and now the two most important tools, I think. On the one hand, you have your graphing calculator, and on the other hand, you have your formula booklet. Okay? I feel like if you master the formula booklet, you're going to master the procedures and formulas, and that also helps you or forces you to also learn the calculator better. See? I feel like the IB AISL specifically, a lot of it is just knowing what your calculator does, to what extent, and how you can use it better. Okay? But for now, let's focus on the formula booklet. So, formula booklet, let's go page by page. As you can see, we have 6 chapters. So first prior learning, and then the 5 topics. Okay? Yeah. For the prior learning, it has areas, volumes, circumference. There's not too much to say here. A lot of it is self-explanatory. What is B? What is H? They tell you. Okay, B is base, H is height, etc. The one thing that I feel like could be worth mentioning here, okay, is this part right here. Yeah, a lot of people didn't learn correctly or thoroughly what x1 and x2 and y1 and y2 means. And as you can see here, it is for signaling different points. Okay, so let's say I have a graph xy, and let's say that this is 1, this is 2, this is 3, this is 1, this is 2, this is 3. So let's say I have a line that goes like this. Yeah. In this context, this first point is, of course, 1, 1. This next point is 2, 2, and this last point is 3, 3. And so let's say that you want to find the distance between 2 points. Okay, let's say you want to find the distance between, I don't know, this guy and this guy, right? You can only mess up this formula, at least in my experience, and I have, so that's why I'm telling you. You can only mess up this formula if you incorrectly substitute x1, x2, and y1, y2. So, what is x1, x2, y1, y2? It will be for pairs of points, okay? This is a pair of points. Actually, no. This is the same thing, really, set of points, okay? So, again, coming back to my example, if I want to go from 1, 1 to 3, 3, just be very, very organized and say, this one is x1. This one is y1, because x1 goes with y1, and this 3 is x2, and this other 3 is y2. Okay, so establish that first, and then you can go ahead and plug in. And one of you might be thinking, oh, but isn't my second point this one? Why are you calling this x2? This is the part where understanding the formulas is very important, because in this context, you define what is your first point and what is your second point. You define it. And you're gonna notice this happens a lot. For a lot of these formulas, you guys, you define what each of these points is, means, etc. Okay? So that's one of the first things I can also maybe put over here. For the formula booklet, one of the tools you will have the day of the test, learn it well, study with it, and also, more often than not, you define what each variable sort of like means, okay? Okay, I'm not sure why I can scroll here. I'd rather have it not be like that. Yeah, there we go. So formula booklet, it's one of the tools you will have the day of the test. Learn it well, study with it, and more often than not, you define what each variable sort of like means. Okay, so in this context, you define what is the first point, second point, etc. Yeah? And so once you started with a formula booklet, you can immediately say, okay, so this is for distance. Okay, this is for midpoint. And so knowing that this is what I mean, like, this is a key concept. this is a buzzword. So the moment you read distance or the moment you read midpoint, you should immediately be thinking, boom, that's in my formula booklet. Okay, for example, paper 1, does midpoint show up at all? Apparently not. Paper 2, does midpoint show up at all? Neither. Distance. It says distance right there. Why is it not? All right, perfect. So paper 2 has a good example for number 2. We can say, or we can see that here it says, write down the distance between B and C. Then it says, write down the distance between A and B. And so some of you might be thinking, okay, I can probably create like a right triangle here. I can do Pythagoras. Like, yes, that works. Okay, it'll work. Don't worry. But the level that I also want to reach is that the moment you read this concept, this buzzword, distance, you're going, I'm pretty sure that's in my formula booklet. Bada bim, bada boom. You jump to this immediately. And so that's what I mean by have the key concept or buzzword associated to a procedure formula. More often than not, it's simply in your formula booklet. Okay? That's the Quiroz math approach. See? Establish the key concept, establish the buzzwords, jump to the formula booklet, and if it's not in the formula booklet, then it's part of the 30% that you just sort of have to know, which I will be showing as we go. Yeah? Okay, let's keep going. So that is for this first part of the formula booklet. The biggest thing, I think, is just distance and midpoint. Okay, that's pretty much it. Whenever they ask for volume or area, you look for it here, you'll find it eventually. Okay? Okay, yeah. Alright, let's keep going. I'm skipping this because it says HL, okay? So I'm gonna go ahead and skip this. Numbers on algebra, topic 1. So, this one is interesting, okay? Because there are 1, 2, 3, 4, like 5 sections to it. Okay, so I'll go one by one. Vale? This first section, we can group, in a way, the first 2 sections. Okay? Now, how would I do that exactly? Well, notice, this is for sequences. Okay, so whenever you're thinking or realize you are in the world of sequences, these are your tools. Okay? Now, up top, I have arithmetic, while at the bottom, I have geometric. And yes, I will explain what it is in a second. Later on, I have for the nth term, and I also have for the sum in both scenarios. So notice, there's 2 equations for each. For arithmetic and geometric, there's nth term, and there's also the sum of both. Okay? And so just knowing that this exists means that the next time you face a sequences problem like this one, okay, you can probably solve it a lot faster. Okay? Now, let's finish the context here. See? Up top is for arithmetic. See? So let's keep in mind that arithmetic is where you have a sequence that is adding or subtracting. So just as an example, we can have something that goes, I don't know, 1, 3, 5, 7. It's plus 2 each time. Yeah? While the geometric is something that is either multiplying or dividing. So it can be something like, sure, I'll do it like that. We can have 1, 3, 9, 27. Okay, so in this case, instead of plus 2, it's times 3, times 3, times 3. Vale? All right, perfect. What are the things you need to know? You need to know clearly, what does UN mean? What does U1 mean? What does N mean? What does D mean? For arithmetic. Well, below, you have to know what is UN, what is U1, what is N, so it's pretty much the same stuff, and what is R. Okay? And this is a sort of scenario where I tell you, look at the description, you'll find a video that helps explain this more thoroughly, more deeply. Okay? But just as a general overview, I will tell you right away, this is what we call the nth term. This U1 is what we call the first term. That is a 1. First term. This N is just well, your n depends on the context. Okay, it depends on whatever you define as nth term. And this d is the common difference. And so in this case, the common difference was +2 each time. While down here, it is the common ratio, which is equal to 3. Okay? The last thing I can point out here, but you will also discover this in the video I'm going to put in the description, is that for the... Let me make a little bit of space. So this is your n. Yeah. Focus really, really hard on the sum of n terms of an arithmetic sequence. So for the sum of n terms, you have 2 equations. Now notice, these 2 equations are not equal to each other. They are separated by a semicolon. So if they're separated by a semicolon, that means that they're completely different. I mean, they get you the same answer, but notice, why are they different? That is why you clicked on this video. It's to learn thoroughly the formulas from the formula booklet, to know what you need to do to learn the correct procedure. So let's say you want to find the sum of an arithmetic sequence, and you have these 2 formulas, you don't know what to do, you start freaking out. Well, hopefully you watched this video beforehand and you can learn, okay, the one on the left, is asking for n, u1, and d. While the one on the right is asking for n, u1, and un. So what's the main difference? Well, the one of them uses d, while the other one uses the n. While the other one uses un. And so depending on the context, you're going to have one or the other. And so, of course, you use one or the other. Or even more than that, depending on the context, you need to ask yourself, do you have everything for that procedural formula? So maybe you're in a scenario where you have n and u1, but you don't have d, and you don't have un. And so discover one of them first in order to use either of the formulas, okay? That is the kind of stuff we need to have in our mentality. That is the approach that I'm trying to go for, okay? So the next time you're doing an exercise like number 9, where clearly you have something that is about sequences, you can see that over here, we have 2 runners that train in different ways. And so the first runner runs 5 kilometers on the first day, so that would be like your U1. And then she runs 2 kilometers on each subsequent day. So that means you have +2 each time. Okay, I'm not sure why this is not like loading my... Wow, that's kind of glitchy. What the hell? Is it saving here? Saving there. Saving there. Why is it not saving here? It's crazy. Right, give me a second, you guys. Opa, 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 opa. Ba-ba-bum. Paper one. Okay, whatever. I'm not sure why that happened. Anyways, so here's number 9. See? So as we can see, once you master the arithmetic and the geometric stuff, you can read this and say, okay, so FG runs 5 kilometers on the first day, so you can already say U1 equals 5. And then this increases, okay, so each time this person trains, it increases by 2 kilometers on each subsequent day. So it's not that it's doubling, it's not that it's tripling, it's not that it's being divided, it's +2 each day. So D equals 2. So you established immediately, once you understand these key concepts, that U1 is 5, that D is 2, and that it's also an arithmetic sequence. That is the level you need to reach, okay? Be quick on the core concepts. While below, for Shumei, we have that runs 5 kilometers on the first day, so again, U1 equals 5. Increases the distance she runs by 13% on each subsequent day. So if it's plus 13%, you gotta multiply by something that's above 1, or else it gets smaller, so it would be 1.13 is your R. And of course, because it's multiplying, it's a geometric sequence. And just being aware of your tools and your methods and what you can use and not use is absolutely essential. And all of this came because you mastered the formula booklet, okay? That is the objective. Let's move on. Here we have compound interest, okay? Compound interest is, you look at it and you should immediately be thinking that it's something about like finance and stuff, okay? Now, compound interest, in my experience, has a lot more to do with the finance app in the calculator. And so what can I say here? And this is the main tip that I'm going to give you. I'm actually going to write it over here, okay? So, in respect to the finance problems, you can sometimes use the formula in the formula booklet, but not always. You can always use the finance app. So I think this is a specific scenario where you should learn the finance app in the calculator, okay? You can learn this formula and it can help you in your approach, but more often than not, you will encounter scenarios where you need to use the finance app anyways, okay? So this is a specific scenario of learning something in the formula booklet that, okay, it can help you in most scenarios, but not all. So what does help you in all scenarios? The finance app, okay? So I'm going to be putting a video in the description for you to learn the finance app really, really well. I'm not going to jump into it right now, but I can tell you that the finance problems, there's usually one per exam or one per pair of exams. See? I have no doubt I'm going to find it somewhere here. There it is. Boom. And notice for number 5, just to show it. So number 5, method point, method point. So 2 out of 5 just for method. And you're probably going to get 1 or 2 of those correct if you're doing the right method. So yeah, on average, you will get like what, 4 out of 5 on this? It's not too terrible. Or at least that's what I think. Ooh, now that I think about it, whoops. Now that I think about it, this one is only 1 method point because this is part A. Damn, that's rough. Okay, so that is 1 method point. See? So the finance, wow, okay. Finance is particularly mean with the method points, I'll be honest. But by the most part, you will have method points all over written in the mark scheme, more often than not. See? I guess the finance app, in this test at least, was a little more mean with that. Kind of surprised, to be honest. But still, what is the main thing I was trying to tell you initially? You have to learn the right approach. Because look, it says you can either do this or that. And once you watch my video, you're going to learn that I suggest this one. Okay? And the main reason I suggest this one is because the one on the right has different values for PY and CY. And I feel like that's a little bit of a hassle to remember. And for me, it's easier to remember that this big N is going to be little n times K, which in the context of the formula booklet is this guy here. So that is like your big N. Okay? And also that this PV is from the perspective of the person. And so the person initially loses $3,000. And that these two, the 12s, okay, are just your K. Alright? Alright. So that is a method that I suggest. I know that was really quick, so that is why I suggest clicking on the video I'm probably going to put in the description. Let us keep going. Back to the formula booklet. Here we have exponents and logarithms, okay? Now, exponents and logarithms do not show too much. Actually, sorry, I correct myself. Per pair of tests, there is at least 1 or 2 exercises with exponents and logarithms. In the case of May 2024, we have 1 log problem right here. Okay, and I think it was for paper 2, we have an exponent problem right there. Okay, now some of you are probably watching this and thinking, okay, there's the exponent problem, but this is part D. Shouldn't the exponent problem start up here? And that is another tip I'm about to give you. So this is a tip or trick. For paper 2, it's, or better said, each exercise is actually 2 problems pasted together. So sometimes you can skip ahead and solve without needing the initial portion. Think about it. For number 1, from A to C, it's probabilities, it's Venn diagrams, it's calculating probabilities and the amount of people and stuff like that from A to C. And then 1D is suddenly talking about some variable and an exponent and how to calculate this. And so this is an excellent example of how for paper 2, you can indeed sometimes skip ahead and solve like half of the exercise without needing the initial portion. And so if you're doing paper 2, okay, and you're freaking out because you read number 1 and you can't solve like anything of number 1, you're like genuinely just like, dude, I can't do this. Take a moment and remember what this guy online said. Okay, not that you should trust guys online, but for math, you can trust me, okay? So, for math, here we are. What I'm telling you is that paper 2 combines problems together. And so this problem is really just like the Venn diagram exercise. And this next one is the variable and exponent exercise. Literally. I can do the same for everything. So for number 2, okay, this is calculating distance. Okay, this one is, although it's like a little more, you know, like related to each other, it's still an example of how you don't need A or B to find some of the other stuff. Like I'm pretty sure that A, B, and C might be like related to each other. More now that I think about it, that's probably what's happening. A, B, and C is related to each other, but you can probably find the rest of it without needing the other stuff. Probably. I'd have to look at more carefully. But generally, okay, so generally, each exercise is actually 2 problems pasted together. Maybe number 3 has a more clear example. Okay, yeah, number 3 is an excellent example. So number 3, part A is asking for trapezoidal rule. It's worth 5 points. So that's really just, do you know the trapezoidal rule? Okay? And if you don't know that, this is the exciting part. If you don't know the trapezoidal rule, you can actually skip ahead and solve this. This does not need the trapezoidal rule. It doesn't. For that, you do not need the trapezoidal rule. Ahora, for the last part, then yeah, you need to combine like the black with the red. See? But it's interesting. Paper 2 is pretty good at like combining exercises with each other. See? So sometimes what you need from part B has nothing to do with part A. Other times, part C has everything to do with part B. Okay, so it depends case to case, and especially in paper 2, you can sometimes skip ahead. So be on the lookout for that, especially if you're clawing for points. Okay? Number 4. Well, this is all just probability of a normal distribution. Probability of a normal distribution. And then the next part is like a chi-square goodness of fit. Okay, it's completely different exercises. It's the same context, but it's different exercises. Literally, okay? Damn, yeah, I mean, this goes on for a while. I'm just saying, see? This might even be 3 exercises together. I think this is the 3rd exercise, yeah. Wow, that's crazy. I usually see up to 2, but look at that. And then number 5, well, you get the idea. I'm not gonna keep going, okay? For paper 2, generally, each exercise is actually 2 problems pasted together, and sometimes you can skip ahead and solve without needing the initial portion. Other times, part A is essential for part B, so it can be a hint. And yeah, this is other scenario where A would not depend on anything for B, and vice versa. And so then you can skip ahead and solve it without needing the last part. Other times it can be a good hint on how to move forward, okay? So if you're stuck, look at part A, maybe it's very associated to it, and it can be a very good hint. The IB loves to do things in order, like whatever you did in part B, you needed something from part A. The IB really likes to do that, okay? And so it can be a very big hint on how to move forward, especially for paper 2. That's not always gonna happen, so you can't skip ahead, see? So this is more of a paper 2 tip. Yeah, back to the formula booklet. So exponent and logarithms tends to show up once or twice per exercise. See? And the hard part here, I think, is first learning how to handle logarithms in your calculator, okay? And the second thing that I can really mention here is the tip of calc intersect. Calc intersect. And I will put this video in the description for sure, because it's probably one of the most important tools you can have. But essentially what you will be doing is that, let's say you have something like, I don't know, 300 equals log base 10 parentheses x. And you don't know anything about logs, and you don't know how to solve this. Let's imagine for a second you don't know anything about logs, see? And you're like, dude, this x is inside the log. Like, what do I do? ¿Cierto? What you can do is using calc intersect, you call all of this y1, you call all of this y2, you graph it. So that means you're going to be graphing 300 up here for your y1. And then your log, I'm going to make this up. It's not how it actually looks like, but let's say that the log ends up looking something like that, okay? And so this would be your y2. So suddenly, if you do calc intersect, and I guess this is a theory you need to know, where two lines meet, / intersect, they are equal to each other. They are equal to each other. So the calc intersect trick can help you find what value makes this whole thing true, what value makes this equal each other. And so wherever they meet, and again, I'm making this up completely. Let's say this is x equals, I don't know, 7. Boom, you just found your solution using calc intersect. Okay, and when I say calc intersect, I mean like you plug this in as y1, you plug this in as y2, and you literally graph it onto your calculator. Okay? Now, I will put the video in this description to explain this better, but the tip I can write here maybe is like calc intersect trick for weird exercises. Weird being something like logarithms or variables on exponents. Okay, because this is also going to happen to you with something like, I think it was paper 2 actually. Something like something like this one, right? And so here in this context, your y is n and your x is this t. And so in this context, your t is in the exponent. I mean, you literally have a scenario where you have, if I were to translate this a little bit, f of x equals 250 minus 240 times 2 times k times t. Now, I think I solved this earlier. I think it's negative 0.1 for k. So this is your context, okay? And let's say that you plug in, I don't know, y equals 5, and you need to find your x, see? So you end up with 5 equals 250 minus 240 times 2 to the power of negative 0.1 times x. And from here, there's a lot of people that don't know what to do. They have no idea what to do. Your variable is on an exponent. What the heck do I do? Like, what's happening? See? Okay, for those moments, we have the calc and intersect trick. So whenever you have weird exercises, or really I should say, you have a lot of trouble getting x alone, or your variable alone, okay? Logarithms, specifically for logarithms and variables and exponents for IB, AISL, the calc intersect trick will work wonders. The video will be in the description. Again, I'm not explaining it now, or else this video would be eternal, and that's not what I want to, give you. Yeah. Back to the formal booklet. The last thing we need to face is percentage error. This one is also fairly simple, fairly straightforward. You just have to have very clear what is the exact value and what is the approximate value. And so really for percentage error, as long as you establish which is which, you're good to go. What's the tip or trick I can give in respect to this? And is that usually in my experience, this shows up for, so this usually shows up for trapezoidal rule and the integrals. And so notice, now I'm going to talk a little bit about trapezoidal rule. Pretty sure it comes up later on, maybe way later on. So I'm going to skip ahead and talk about trapezoidal rule since it just came up, but it is associated to the what's it called? The percentage error. See? Yeah, so for trapezoidal rule, I have a couple of videos explaining thoroughly what each of these things mean, okay? And if I were to do an extremely quick summary, this would be first, it's too big. Let me try again. So this would be first and last y. All of these over here would be all other y's. Okay? H, you have it defined down here. A would be your first x, and B would be your last x. Okay? Now notice the trapezoidal rule, the intuition I can share with you is that it is for area under the curve. Now, what is area under the curve, but how? See? So paper 2 over here asks you to use the trapezoidal rule from 0 to 4. And so what does a trapezoid look like? Well, basically what you would be doing here, okay? What you would be doing here is drawing this trapezoid, drawing this trapezoid, drawing this trapezoid, and drawing this trapezoid. So if you were to take these 4 trapezoids and add them all together, it's pretty much the area under the curve, right? However, there's a little bit of space here that we're not accounting for. So that is why the trapezoidal rule is excellent for finding the area under the curve, but as an approximate value. And so that is why the percentage error usually shows up, because the trapezoidal rule, remember, is the approximate, while the integral is for the exact. So what's intuition I can share with you? Trapezoidal rule is approximate value of area under the curve, while the integral is the exact value of area under the curve. And more often than not, this is followed up by a percentage error question, which is, okay, you have the approximate, you have the exact, what's the difference, right? What's the difference? And so, yeah, it's pretty much all I can really tell you about, what's it called? The percentage error and the trapezoidal rule. I'm not going to jump into what each of these things mean. I gave you an extremely quick definition, okay, for understanding this formula, but I invite you to watch the video and understand it more thoroughly. Trapezoidal rule, in my experience, always enters at least once. What's another way to remember that we're talking about approximate and not exact? This thing on the left, okay, is literally an integral. So this is what we call the exact value. And all of that will be your approximate. And how do you know it's an approximate? Because it's not using an equal sign, it's using a squiggly. So when you use a squiggly, it's an approximate. Ah, look at that. So the trapezoidal rule is the approximate to the integral. Interesting. Interesting. Yeah, let's keep going with the famous formula booklet. So we just finished, as far as I know, we just finished topic 1. Yeah. Now we can jump ahead to topic 2. Here we have the functions of the functions section, see? So there's 3 main tools you need to know: the equations of a straight line, the gradient formula, and the axis of symmetry of the graph of a quadratic function. So the key concepts that can arise here is understanding really well what is axis of symmetry, okay? So I'm actually gonna start with that one. Axis of symmetry of a quadratic function. Establish immediately quadratic function, you need to know it as a parabola. Okay, most of you know it as the parabola. It looks a little bit like this, or also like that. The other thing you need to establish is that the axis of symmetry, because it's for symmetry, parabolas are perfectly symmetrical. Like the left side is the same as the right side, it's just kind of like mirrored, see? So left side, right side, well, right down the middle is the axis of symmetry, and I can say the same about this diagram on the right as well. So that is for the axis of symmetry. How do you find the axis of symmetry? You plug in negative b over 2a. What is b? What is a? This b and that a. Notice, it gives you, so negative b over 2a gives you the x value for your axis of symmetry. And the big brain thing I can share with you here is that this x value that you get from the axis of symmetry, okay, will be the same as the max or min. Same x value as the vertex. And let's remember that the vertex is the same as the maximum value or the minimum value. The vertex is always the optimal point, so maximum or minimum. So yeah, if you ever need to find the vertex, the max or the min, you can consider using the axis of symmetry formula. Okay, so that's the kind of stuff we need to be like quick on. In respect to equations of a straight line, this is a big tip, okay? Usually when I teach this part, most people are like, oh my god, really? And I'm like, yes, really. So hopefully you have that moment. This right now is 3 different equations for straight lines. And what most people struggle with is understanding which one do you use when. And what I will tell you, and write this down somewhere, or just download this PDF later, is always start here. I have never had a situation where I can't start here. You can always start here. And so for using this formula, so again, this is the key concept would be like create a line or something like that, or they give you slope, they give you a point, create the line. So basically this is a guide for creating a line or creating the equation of a line. So for creating the equation of a line, this guy online told you always start here in the thing that I'm putting in pink. So always start here. And what do you need to fill in? You need to fill in y1, x1, and m. So that means you need to fill in m and the set of points. That's literally it. What I'm trying to tell you is that for creating the equation of a line, you only need the slope and a set of points. And you start here and end up there. And from here, you can also end up there. Let me give you a quick example. Let's say that the slope is, I don't know, 3. And the set of points is whatever, 7,4, okay? My formula is y minus y1 equals m parentheses x minus x1. So if I go ahead and plug in, you plug in y minus 4, because this is y1, equals m, which is 3 parentheses x minus 7, because this is x1. So y minus 4 equals 3x minus 21 plus 4, we do some quick maths, y equals 3x minus 17. And so notice, you started from this structure here, and you ended up in this structure here. And if you, so I just went from here to there, and if the IB, because they do this sometimes, not often, but they tell you to leave your answer in this form, then all you have to do from here is, well, you need to equal it to 0 and hopefully have your x being positive, okay? So from here, you can go ahead and just, you know, leave it all equal to 0, so you can do minus y minus y. You can end up with 3x minus y minus 17 equals 0, which bada bim bada boom is literally the same format as ax plus by plus d equaling 0. So the main thing that you should take away from this is that for creating the equations of a line, you gotta use this guy here. So important that I'm actually gonna write it down here. Whenever you have to create the equation of a line, use the point slope formula, which only requires the slope. So what does it requires? The slope and a set of points. The point slope formula is y minus y1 equals m x minus x1. And this is, by the way, it's in the formula booklet. Okay. And you also have, you know, for gradient, you have the slope. So if you need to find m, you can also use this. Not bad, not bad. that is something a little more quickly for topic 2. Topic 3 gets kind of crazy. Topic 3, we are finally talking about geometry and trigonometry. Not too exciting, but absolutely necessary. So here you have the distance between 2 points in 3 dimensions. So if you ever have something like this, where you have x, y, and then z, doesn't happen too often with AISL, but it can. You will have a point, for example, something floating here. See? So this would be like, how would that be actually? How do I graph this properly? There. So let's say you have something that is, I don't know, x of 2. Then it's a y of 3. And then it's a, and then it's whatever, z of, I don't know, -3. So your point would be 2, 3, -3. And you might have to find the distance from this to another one. Well, you would be using this formula here. So if you ever face a situation where you, again, you need to find the distance, this is the key concept, or the midpoint, this is the other key concept, of something with 3 dimensions, well, here you go. Don't get scared. This is the only thing they can ask you for 3 dimensions. Yeah. We keep on reading and we can establish stuff like volumes, right cones, curved surface area, blah, 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 blah. I guess the only thing I should really explain here, I think, is that slant height is not exactly your usual height. So this is for a cone, see? So the cone looks a little bit like this. And so slant height is this guy here. That's your slant height. Very, very different than like your so-called actual height. Okay? It's a little bit different. Careful. That's the one thing I can mention for that area. The more important part, I think, is right over here. This is something you're going to end up using way more. Okay? And again, this is one of the specific scenarios where you either know it or you don't, period. I need you to associate this to trigonometry. And I need you to associate this that I'm putting in red to circles. And once you do that, you're good to go. See? For trigonometry, the quick sort of summary I can give you, and something you should really keep in mind, is that these 3 formulas for trigonometry have big letters, little letters, and a bunch of stuff like that. Immediately I will tell you, and I will put it in the description so you learn it better, small letter is for a side, while big letter is for a angle. So how does this work? Let's say that this is angle A, then this is side A. If this is angle B, then this is side B. And if this is angle C, then this is side little c. Okay, so for side rule, I need to have clearly just a couple sides and I'm good to go. See? So if you have a pair of a side and an angle, you can already use sine rule. What do I suggest for trigonometry? And again, this will be in the description so you can check it out. What I suggest for trigonometry is to, let me write that here actually. So for trigonometry, first try sine rule. If you can't, use cosine rule. That's literally it. And if you still can't use either of them, then probably there's like an angle you have to find using some other method in order to attempt the use of sine rule, or in order to attempt the use of cosine rule. But your priority should be use sine rule, then use cosine rule. That's pretty much it. I'm not even kidding. The video I will put in the description explains it a little bit better, why it works like this, and etc. And the last sort of thing I can mention is that also area of triangle, 2 formulas. There's a formula for area of a triangle in the trigonometry version, which is right here. And I will jump into this one a little bit more because I think it's very important. This also gets asked roughly once per exam session. Basically, you have side A, side B, and angle C. And so in this example here, this is angle C, and side A is next to it, and side B is also next to it. So what is the main conclusion here? For area of a triangle, you can find it if you have an angle and the two sides next to it. If you have an angle and the two sides next to it, you can already apply the area of a triangle formula with no problem. So much so that there are exercises they can only solve with that equation. For example, right here, number 2. Let's go ahead and apply the Quiroz math method. Okay, so the Quiroz math approach is that you look at this, you see a triangle, you need to find distances, you need to find angles. You should already be thinking in trigonometry. So you think of trigonometry and immediately you open up your formula booklet. You open up your formula booklet and this guy told you use sine rule first, if not go to cosine rule. Okay, bada bing bada boom. And after that, that's it. That's the method. Use sine rule and then cosine rule. Understand them well. Watch my video. And in respect to the area of a triangle, I think it was down here. So down here, you can read the exercise on your own later, but basically, for this part, you need to find the area of this triangle. And what they give you is the radius of the circle, which equals 8. So you know that from here to here. Oops, actually, sorry, I'm trolled. You need to find the area of, yes, you need to find the area of this triangle. And they tell you that AC is 21, this whole thing, and also that AB is 15. And so look at that. You have an angle and the sides next to it. You have an angle and the sides next to it. And so boom, if you need to find the area of this triangle, you can just use, for the area of the triangle, it's going to be 1/2 times 21 times 15 times sine 78. Just like that. And so being quick with that kind of stuff, realizing you need to find the area of a triangle, realizing that you have more than one option, specifically the trig one, boom, that gets you the point. And so that is why mastering the formal booklet is so important, because a lot of these exercises, you either know your tools or you don't. The big idea here is know and learn your tools. That is why I push so much for studying with the formal booklet. Almost all of your tools are in there. I'm not even kidding. And so this exercise, number 11, you cannot solve it if you don't know that this formula exists. I'm not even kidding. There's a couple more examples like that. But my main idea, study with the formula booklet. It has a lot more procedures and formulas than what you think. Learn the key concepts, learn the key buzzwords to reach these formulas, to reach the correct methods. All right. Then we have length of an arc, area of a sector. Again, an example where it's extremely easy, but you just have to know that these tools exist. The main thing I can sort of point out here is that what is an arc, what is a sector? Let's say you have a circle like this, or actually, example I like to give. Let's say you have a Pac-Man that goes like that. Waka 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 waka. In this circle that I just drew, okay, what is the arc and what is the sector? Let's imagine for a second that this is 30 degrees, okay? So, in respect to those 30 degrees, notice, in respect to those 30 degrees, the arc is this and the sector is that. So the arc is this, while the sector is that. So boom, you can already associate that arc is sort of like the distance alongside the circle. That alongside looks terrible. Alongside the circle. Well, the sector is going to be the area I guess, formed by that angle. By the angle. And so understanding that well is essential. I'm pretty sure I'm gonna upload a video explaining number 11 anyways, so you can check it out here. But you actually use the sector formula right here anyways for finding that area in this exercise. And actually you can also use it to find the area of this sector. It's a bigger sector, but it's still a sector of this whole thing. All right. So yeah, I'll again check the description for all these sort of ideal examples, or at least what I consider the ideal examples. Here we have HL, so we're gonna go ahead and skip it. And now we have statistics and probability. Okay? Interquartile range doesn't always get asked. This one is a little more... This one doesn't always get asked. Usually it's for more of a paper 2 question. Yeah, I don't think it's gonna show up here. Nope. But interquartile range, just understanding what Q3 and Q1 is absolutely essential. I will be putting the video in the description to explain it. For now, when you have a set of data, okay, and this is best explained with a box and whisker. When you have a set of data, something that maybe looks like this, okay? Here on the left is the minimum, here on the right is the maximum. In the middle is, of course, the median. Now, the median is also called the Q2. So median equals, let me write that better. This median equals Q2. Now, why would it equal Q2? Well, the Q's are in quarters. So think about it this way. Q2 means 2 quarters. So it's 2 times 25% is 50%. So the median Q2 is exactly at 50%. That's why this Q1 right here is 25%, and this Q3 over here in total is 75%. And so technically from here to here, it's 25%. From Q1 to Q2 is 25%. From Q2 to Q3 is 25%. And from Q3 to the maximum is another 25%. Okay? Again, watching one of my videos explaining it better and applying it to an actual exercise is probably going to help a lot more. But there is interquartile range. See? The mean set of data, for this part, I'm actually going to jump to this paper here and show number 1. There's a couple exercises where you need to know how to find the mean, how to find the standard deviation. And what does range mean? These are a bunch of key concepts that actually do not show up in the formula booklet. Okay, you have a formula for mean, but not for standard deviation or range. And so this actually has a lot more to do with understanding well your graphing calculator. Again, I'm gonna put an exercise like this in the description, but just to show you quickly, because I think it's pretty worth it. Okay, for solving this, you can go to your calculator, click stat, then edit, and put in your list of data. Then go to stat, calc, one of our stats, because it's only one variable. Go ahead and press calculate, and a bunch of stuff shows up. Okay? Now, the reason I'm showing this on video live is that for the range, for the mean, for the standard deviation, a lot of this is going to show up here. But you're not going to be able to get it or understand it unless you know what your calculator is saying. So notice, here's the Q1, here's the median, here's the Q3 that I was talking about earlier. So having that kind of stuff in mind, knowing what these things mean within your calculator is essential. It actually comes back to a little bit this idea. The 2 things you need to know really well are the formula booklet and the calculator. So for this exercise, that usually there's one per test that asks for mean, for range, for standard deviation, pop it into your calculator, and here's what you need to know. Okay, what you need to know is that this symbol is your mean. The other thing you need to know is that this symbol is your standard deviation. So again, this is the kind of procedure or exercise that you either know it or you don't, so that's why I'm here telling you. This is part of the 20 to 30%, 30 to 40% that is not in the formula booklet, but you do need to know how to do it. So whenever they're asking for range or mean or standard deviation, this is how you do it, okay? And for the range, just like that, this is not interquartile range. There's two types of ranges. So you have the range, which is this, which is like the max minus min. And then you have the interquartile range, which is a little bit like the range of like the middle portion of your data, because as you can see, the interquartile range is between Q1 and Q3, so it's the middle 50% of your data. While the range is the range of your entire data, the max minus the min. All right? So for the range, using my calculator, I can go ahead and find that the minimum is 9. Damn, is it 9? I must have written it incorrectly. Oh yeah, see. So this should be 99. Whoops. Okay, apologies. Whoops. So just to follow the example, boom. So the minimum would be 49, as you can see, the minimum x, and the maximum x is 255. So for range, it's the max minus min. Okay, so in this context, it would be the 255 minus the 49, which is the same thing that shows up here, the 255 and the 49. All right, that would be for the mean, right? Here for probability, it's a little bit trickier, I'll be honest. See? This is more of a scenario where you should definitely click on the video in the description. I know I'm saying that a lot alongside this video, but I insist, I can't explain this thoroughly or else this video would be eternal. Okay? But the main thing I can point out here is that, okay, you gotta learn these formulas and everything, but really, for these, you just need to know that they exist. So know that they exist for these two. Because in my experience, what happens is that every once in a while the IB likes to put something that's like, are these events mutually exclusive? Are these events combined or not? Are these events this or that? And this is your way to prove it. Because if they are mutually exclusive events, this has to be true. Okay? What's the other thing I can mention? Some of you are probably confused by what these symbols mean in the first place. This associated to or, while this associated to and. And so the probability of A or B for combined events is probability of A plus probability of B minus probability of A and B. Alright? This right here for conditional probability, I need you to associate this to given. So the way you would read this is that A given B equals the probability of A and B divided by B. Literally. Okay? And the last thing I can mention is that in the world of probability, and you will see this if you click on one of my videos, whenever you're thinking in terms of and, so if you're thinking in terms of and, you multiply. You multiply. If you're thinking in terms of or, you add. Okay, and this is in terms of probability. That's also why these independent events are multiplying each other. Because you think in terms of and, so they multiply each other. See? Yeah, let's keep going. For expected value, this is something that I explain in my videos a lot. What I can mention is that this does show up at least once per paper. An expected value, it's really just going to be the probability of your thing multiplied by the amount of times it happens. Okay, that's all it's saying here. The probability of your thing multiplied by the amount of times it's happening. Okay? For example, and let's try to keep it simple. Let's say that probability of heads or tails is 1/2. See, so heads is probability of 1/2. Let's say I flip, I don't know, 10 coins. So what should I expect? How many heads should we be getting? We should be getting 5. And for you, it's kind of obvious. It's like, 10 coins. You flip them all, 10 times. Sorry, 10 coins, you flip each of them once. On average, you're going to end up with 5 coins. That's your expected value. It's just that in these exercises, expected value is a little bit different. Okay, I mean, it's not that it's different, but it's harder to catch. Okay, instead of just doing 10 times 1/2 equals 5 for number 8, you can see that you end up with a little bit of a longer sort of table. So you actually do this times this, plus this times this, plus this times this, which is exactly what's happening here. Okay? Now, click on one of my videos, you're going to learn it a little better. But notice, just for attempting the expected value, you get a method point. So it's good that you know that it exists. See? So I guess the bigger tip here that I can give you is that this does show up at least once per exam. Binomial distribution is a little too complicated for me to get into in a quick way. Usually you don't need the mean and usually you don't need the variance. What you do need to know for binomial distribution, and actually it's the same for normal distribution, so I'm actually going to put that as a thing here. For normal distribution and binomial distribution, you need to learn for the normal, you need to learn inverse normal, normal CDF, and normal PDF. Well, for the binomial, you need to learn the normal CDF and you need to learn the binomial CDF and binomial PDF. What the heck am I talking about? I'm talking about your calculator. Again, if you have no idea what I'm talking about, you should click on one of my videos, you'll figure it out. I'll put the description. Basically, you need to go to distribution, because we are talking about distributions, and the tools that you have are normal PDF, normal CDF, and inverse normal. Okay, that is for the normal distribution. So learn those 3 tools and you'll be good to go for the normal distribution. Not even kidding. Well, for binomial, you gotta know these down here, way down here. Binomial PDF, binomial CDF. See? If you know those, you'll be good to go. See? The intuition I can share with you for now, although click on the video will help you a little bit more, is that inverse normal is like you give area, get x. Normal CDF is give interval. So give interval of x's, get area. And this last one is give x, get area. So inverse normal is something like, I don't know, the top 35% of my distribution is whatever. Let's say you're talking about the weight of babies, and so the top 30% of your babies are this amount of weight. You or discover what amount of weight have the top 30% of babies. You use inverse normal. Okay. Normal CDF is more like, of my babies, which of them weigh between, I don't know, 1 and 2 kilos. I'm making it up. I don't know the actual weight. You plug in between 1 and 2, you get the area. See? Binomial is a similar idea. See? So CDF is also for intervals. Okay? So that repeats. And PDF is also for give a value, get the area. Okay, so the CDF and PDF logic is the same. Yeah? Alright. If I keep going and skip all the HL stuff, here we have, well, the trapezoidal rule, I already explained it a little bit. We also have the derivative and the integrals. See? So, derivatives and integrals, the main idea I can share with you is that the moment you do the derivative, this, like your y values, now become slopes. Okay? Once you do, let's say you have something like this. It's a quadratic function, see? And let's say that somehow you get your hands on the derivative version. If you say that the derivative version equals 0, then you're saying that your y value for the derivative version equals 0. And so basically what's happening in red is that you're asking your function, when my slope is 0, what is my x? And so if your derivative version equals 0, then you're saying, okay, if my slope is 0, it's a horizontal line. Where can I draw a horizontal line on this graph? Well, here it would be still growing, right? Meanwhile, here, it's a horizontal line. And so, boom, a lot of times for derivatives, the reason you do them is that you equal them to 0, and this helps you find the max or min. Because notice, this horizontal line is perfectly on the vertex. Perfectly on the vertex. Yeah, and the integral, okay, is more for finding area. So I need you to associate integral for finding like the area, okay? While derivative is more for finding slopes. Or for using slopes, okay? All right, excellent. How do these actually work? Again, video in the description. But for derivatives, focus on how the n behaves. The n does two things, okay? So it's gonna multiply in front. And it's also gonna get a -1 to the exponent. The integral is a little bit more weird, but again, check the video in the description. Yeah? I'm much more concerned about you associating integral to area and derivative to slopes. Alright? Alright. And that would be for topic 5. So by now, I've pretty much explained pretty much everything from the formula booklet. See? And just so that you believe me, now we're going to go through the paper, except for the ones we already established. We're going to go through the paper and see, okay, and see how we can use the Quiroz math methodology. So remember, the Quiroz math methodology, the Quiroz math approach, is identify the key concepts and buzzwords, associate this to the procedure or the formula in the formula booklet, make sure you have everything you need in order to use that procedure or formula, and then go ahead and solve. And of course, there's a couple things you need to be aware of within these formulas, you know, the best approach. For example, here the best approach is using the point slope formula, the y minus y1 and parentheses x minus x1 for creating equations. Maybe area of a triangle, remember you have two formulas, yada 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 yada. So, just to prove it, for number 1, what are the key concepts we established? Range, mean, standard deviation. Immediately you should be thinking of the graphing calculator, putting this into 1var stats. And so establishing that as your procedure, especially since they're asking for standard deviation, doing that will give you the method. And then you're gonna get most, if not all, answers right. For number 2, you can establish its trigonometry, so immediately you can say, okay, for whatever they ask, I first need to try the sine rule. And if it doesn't work, I go to the cosine rule. And if I still can't use it, then I should double check, see if I can create another sort of whatever. Find an angle, find the missing side, etc, etc. For number 3, this is a section of the explanation which is not within your formula booklet. Okay, so this is a kind of procedure that you actually have to be aware of and learn a little bit more about what to do correctly here. So number 3, you read it and immediately, oof, significance level. So whenever you talk about significance level, null and alternative hypotheses and stuff like that. So this is something new that will arise, and the big hint I can give you here is that for all of these different statistical tests, null hypotheses is like the status quo. So it's a little bit of like a no change scenario. While the alternative hypotheses is like yes change. Okay? And it heavily depends on what, so both depends on the investigator. Alright? For example, here, Sunita wants to test if the size of the peppers is independent of the color. It's not trying to test if it's bigger or if it's smaller, it's just trying to test if it's different. So I bet that the null is going to be something like the, you know, the average of the first group does not equal, okay, does not equal the average of the second group. Well, the alternative is going to be that, well, actually, wait, I messed up. The null is the status quo, it's just no difference, okay, no change. While the alternative is yes change, so that means my averages are different to each other. And if we look at the answer key, it's something like that. See? the size of the peppers is independent of color, or the size of peppers is not independent of color. So basically, when they say that it is independent, it's going to be that they're equal to each other, and not independent, they're not equal to each other. See? So here, again, I read it really quickly. I just put the mean. Didn't realize we were not talking about means. Oops. But I can portray the idea that the null is no change, while the alternative is yes change. Okay? And really from there, all you have to realize it's what it's actually asking for. So the chi-squared statistic, and here is something that I can help you with the procedure. For the chi-squared, within your calculator, you go to, where would you go? Give me a second. Yes. You go to stat, go to test because it's a statistical test, and look for chi-squared. And you're going to find two of them. Chi-squared test and chi-squared GOF. And so what you need to reach is that you read chi-squared. You know it's in your calculator. And you end up finding two. You find one that's like the normal one and one that says GOF. And so from here, click on both, figure it out. Click on this one, it has these big letters. And so these big letters is for a matrix, which I need you to think about it as just like a table. Okay. Meanwhile, the other test is looking for a list. So GOF is for list. That is the level you need to reach. Okay. Notice the Quiroz math method reaches here. You recognize chi-squared calc. You don't freak out. You know it's in your calculator because you've been studying with your calculator. You know where to find it in your calculator. And you know that there's two versions. That's all you know. You probably don't remember which one is matrix and which one is list. You probably have no idea. Okay? But you know that there's two of them. You're going to click on them and figure it out. Okay? That is why the Quiroz math I think is so powerful, because it's not about knowing everything, because that's not exactly realistic to know everything. But you do need to know that the chi-squared thing is in your calculator, and you should have the intuition that there's more than one, and you'll figure out which one to use. And just by clicking on it, you realize one of them is for a list, another one is for a table. So this, is it a list or a table? That looks like a table to me. And so if we look at the answer key, it doesn't even show here, but yeah, it would have been like the OG one for the matrix. You put this whole matrix into your calculator. Yeah. For number 4, here we have, just reading really quickly, this is more of a functions problem. See, so this has more to do with your intuition with exercises and functions. The only thing I can really sort of try to mention here, okay, is that you have the word like the brick varies inversely with the number of brick layers. Okay, this is more of an exercise of interpreting the function and creating the function. This is more like just mathy math. Okay, there's not too much of a procedure you can apply here. Okay, this is more about knowing how to create functions, and practice makes perfect. Okay, this is one of the few examples where it's like it's not in the formal booklet, it's not in like, I can't really give you like a to-go-to procedure. You just kind of have to have the intuition of how to build it with all your years of experience in math. So this is a specific exercise that you have to be really finite in your approach. You have to really have a good math intuition to solve it. So not everyone's gonna get this. Don't feel bad about it. If we look at the answer, clearly it's the word inversal was for the reciprocal. See? So this is awfully specific. It's a tough one. That's also one of the tips I'd like to mention. And this is not only just for a B, it's for test taking in general. Focus your time in what will be most efficient. Maybe it's not worth learning number 4 because it has a lot to do with math intuition. It's awfully specific. It's nothing in the formula booklet. It's nothing in the calculator either, by the way. See? What I suggest is focus your time on what will be most efficient, which is the formula booklet and the calculator exercises. Number 4 has nothing of that. It's just mathy math. You can either do it or you don't. I really can't say anything else. Okay? So, of course I'm going to upload a video solving this, but the main tip I can give you is spend your time where it's most efficient and in the most reliable way, which is going for method points, which insists that you learn the formula booklet and you learn the calculator well. So number 4, don't stress about knowing everything perfectly. Stress about knowing enough of it perfectly. See? The enough being formula booklet and calculator. Number 5 is clearly a finance app problem. Just by looking at it, how would I know the key concepts? Invests, compounded monthly, nominal annual interest rate. So boom, you establish it's a finance app. You go to the finance app. Once you know it well, you plug and chug. It's fairly easy. Number 6, if I read it quickly, we have this is a little tougher, but this should be binomial. Yep. So binomial is a little bit harder to spot. See? Well, once you spot or have an eye for binomials, then you can use your binomial tools, which, as I said, were these two right here. Binomial CDF and binomial PDF, literally. Okay? So once you establish it's binomial, you go to those tools, bada bing, bada boom. See? How can you realize this is binomial? Okay, that's the hard part. See? How do you realize that these are binomial? Binomial probabilities are usually, think about it as like heads or tails. So here we have that Jerry, it's either flawed or not. So it's either heads or tails. It's flawed or not, heads or tails. So if it's between one of two possibilities, it's binomial. That's also why it's bi for 2, bisexual, by this, by that, binomial, 2 options, 2 scenarios. Okay? And so basically here it says in a batch of 20 chocolates chosen at random, find the probability that 2 are flawed. That's exactly 2 being flawed. More than 2 being flawed, that would be binomial CDF. So this is binomial PDF, this is binomial CDF. Immediately I can establish that because 2 are flawed is exactly 2. And if you're thinking in terms of exactly, you're using PDF. And if you're thinking about between an interval, or actually, yeah, I should say interval. And if you're thinking in terms of an interval, so 2 or more, CDF. And so that is the Quiroz math approach, okay? Realize they're asking for a binomial. That's the hard part, I admit it. But after that, it's asking for exactly 2, PDF. It's asking for an interval, CDF. That is about knowing your tools, knowing what you can do, knowing what you have. Number 7, logarithm. We already talked about it. Essentially, I think I wrote it here actually. So logarithms, calc intersect is going to help you for these scenarios. Okay, that's pretty much it. Here it is just a hardcore probability problem. Not too much on the form. I mean, there are stuff in the formula booklet, but this is more about understanding probability. And the biggest thing I think for understanding probability is having very clear and is for multiply or is for adding. Usually having that intuition is good enough. Okay. For most cases. But yeah, in the description I'll put exercises for probability for sure. See? Number 9, sequences. We already talked about it. Being able to identify arithmetic and geometric, and knowing that you have these 4 formulas up here. See? Oops. These 4 formulas, right? Yeah. Number 10. Oh, here's a good example of something that is awfully specific and is not in the formula booklet. And I will explain now because this does show up once per exercise. Normal to the curve. Guys, if you have a quadratic that looks like this, and I task you with draw the tangent and the normal at x equals 2. The first thing I need to establish to you is that tangent is sort of similar to the normal. It's not that they're the same, but I at least group them as concepts. And so at x equals 2, let's say that it's right here. The tangent you've probably heard of before. The tangent is something that touches once and then never again. And the cool thing about this tangent is that right at that point, the tangent has the same slope as the original. So I'm actually going to write that down here. The tangent at that point has the same slope as the original. Meanwhile, the normal, which I'm going to draw now, in something like maybe this green, the normal would actually look like this. So let's imagine for a second that the red one has a slope of, I don't know, 3. Well, then that means that the slope of the normal, and I'm going to try to help you figure it out on your own. If the slope of the tangent at x equals 2 is 3, then the slope of the normal at x equals 2 has to be negative 1/3. So how do I associate the 3 to the negative 1/3? I'll give you 10 more seconds to figure it out. Okay. The normal at that point has the negative reciprocal slope as the original, which really, in more intuitive terms, let's be honest, is that it's the perpendicular. It's the perpendicular slope. And you probably have seen this in class at some point, but perpendicular slopes, you can face parallel slopes that look like this. And then you can face perpendicular slopes, which look a little bit like this. And there's 90 degrees all around it. See? For parallel slopes, you have that if this is all 1 and this is all 2, you have that the slope of the first one equals the slope of the second one. That's why also they never touch. Meanwhile, a perpendicular line, let's say this is all 1, this is all 2, you have that the slope of the first one times the slope of the second one equals negative 1. And so technically, if you want to get m1 alone, you end up with m1 being equal to negative 1 divided by m2. And so that is why, in your experience, you've probably heard that perpendicular slopes, you just have to like flip it and multiply by negative 1. Because look at that. If your slope of m1, my example up here, equals 3. So if m1 is 3, for m2, I just have to flip it. So I'm going to put the 3 on the bottom and then multiply by negative 1. Which is the same thing that happens to here. Quite literally. Alright, so that is for perpendicular slopes. So here I'm actually going to write it somewhere. Okay. It's probably worth putting here. Stuff that shows up at least once per exam. Well, most of these things, okay, but the ones that really catch my attention and not necessarily in the formula booklet, but I do think it's important to have in mind, are the area of a triangle trig version. And so this would be in the formula booklet, lol, but it does show up once per exam, I think. This thing called bearing, which will show up later, and this thing called the normal associated to tangent. So these are sort of like key concepts that are not necessarily in the formal booklet, but that generally show up once per exam. Yeah. I'm pretty sure bearing shows up later, so let's just keep going. Yeah, number 11, we can immediately say that it's a trig problem because there's a triangle pretty much, and also a circles. So trig problem, you can associate your 3 tools: the sine rule, the cosine rule, and the area of triangle. And so just being aware that these are your tools help you visualize earlier that I can find the area of this using the area of a triangle version. See? And knowing that we're talking about a circle here, you know that you have the formula for length of a arc and area triangle. All right. For number 12, just reading quickly, derivative. Derivative. Exact. Actually, no, that's a little bit different. Well, find the derivative, and right after the derivative, I told you at some point, you want to equal your derivative to 0. At the time I expressed it like this. Now, why do you want to equal your derivative to 0? Because that is where, in your function, the slope equals 0. And wherever the slope equals 0, you will have the maximum or minimum. So look at that. The exact value when the area is a maximum. Well, look at that. You have to equal this to 0. And I am so convinced, because of the structure that keeps on repeating, you get the derivative, then they ask for the maximum or minimum. You gotta take your derivative and equal to 0. I bet number 12 has that in their mark scheme. Look at that. Set the derivative to 0, method point. That's what I'm saying. That's the kind of thing you have to be aware of. Okay, cool. What are the other tips I can sort of try to show you? And this is a lot more specific, so if you're still watching, good for you. Awfully specific, but here it says show that. So if it says show that, you know that it's true. So this is a scenario where you can assume for part B that this is true. So that means that if you're stuck on part A and part B and cannot do it, but you notice that it says show that, you can take this as true and solve part C doing the derivative of that. And you might be thinking, okay, but I never got that. So you're told, oh, but they're giving it to you. It says show that. So be very aware of where you can skip ahead in order to claw for points, okay? Yeah. And also this hence is a big hint that whatever you did in part D depends on something from part C. Which makes sense. You had to take the derivative and equal it to 0. So the hence is a big hint of whatever you did earlier, you need it now. Or better said, because of what you did earlier, you can now do part D. Alright, so that would be for paper 1 and for paper 2. Just to finish showing that this method in general works pretty well. This one is more of a Venn diagram problem, okay? Doesn't always show up per test, but it is getting a little more popular to do it, okay? Part A is just learning how the Venn diagram even works in the first place. And identifying this given, look at that. That's what I'm saying. Identifying that it says given here immediately should remember you, given for probability, given. And so identifying that word that says given is the hint that you need to use conditional probability. That's what I'm trying to portray to you. And hopefully if you watch the whole video or at least part of it, you have now learned that identifying these buzzwords can be big hints on how to move forward. So the moment you read given, you should be thinking, okay, conditional probability, bada bing, bada boom. This formula, yeah? For this section, we are talking about variable and an exponent, so not much to mention here. What I can mention, however, and this is awfully specific, but I'm still gonna do it, is a quick tip or trick. Here, it says, comment the appropriateness of Diego's model. And so notice, sometimes you can skip ahead, especially when it's worth 1 point. There's a couple of what I call context questions. Whenever there's context questions, they're usually worth something like 1 point, see? And so you can answer this without answering anything else. So sometimes you can skip ahead, especially if you have, 5 or 10 minutes left and you're stuck on a problem, you can't solve it. Try to find a context question at the very end, which is worth 1 point and doesn't need anything from before. See? I mean, the only thing you need is this. Interpreting this and this. You don't need D, E, or F. You just need what they tell you here and what they tell you there. And so be aware of those context questions if you're trying to claw for points. Certain questions that don't need anything from before and you only need the context of the question. That's why it's called context questions. Yeah, here again we have distance for distance formula. Bada bing, bada boom, easy peasy. Here we have bearing. So bearing is something I didn't explain earlier, okay? But just to finish with the question before I talk about bearing, here we have gradient, here we have midpoint, okay? And so just with that, you can already use the formula booklet for almost all of this problem, see? Bearing is a little bit different. I have a couple of exercises explaining bearing. I will put it in the in the description. One that I think is very good for explaining it. But bearing is something that does show up at least once per exercise. Just knowing it gives you 3 easy points. How does bearing work? I'll give one extremely quick example. Let's say you start at home and move 30 meters in a bearing of 30 degrees. So if you start at home and move 30 minutes in a bearing of 30 degrees, it's like this. How did I figure that out? How did I just do that? Well, the way bearing works is that you should always think about it first with your north. So draw your north, and then since it says bearing of 30, draw lines until you reach 30 degrees. And so 30 degrees is just around, I don't know, if this is 10 degrees and this is 20 degrees, then yeah, 30 degrees is around here. So boom, there's your bearing of 30, and you do this for 30 meters. Now some of you might be thinking, how do you know this is a bearing of 30? Well, because if this is my north, a little bit like a compass, see? Straight east is 90 degrees. Straight south is another 90, so that's 180. And straight to the west is going to be 270 degrees. Well, and coming back is obviously like 360, see? So now that you know that, if you say you start at home and move 5 meters in a bearing of whatever, 255 degrees, then you know for a fact that the 255 degrees is between this 270 and this 180, right? Let me associate this a little better, or just explain it a little better. Straight east is 90 degrees. So straight east is 90 degrees. Straight south is 180. Straight west is 270. And if you come back north, it's, I guess, 360, which is the same as just not moving. See? So if you say you start at home and move 5 meters in a bearing of 255, well, the 255 is between 270 and 180. So you can start at home and know that you need to aim somewhere in this direction. Bottom left, southwest, southwest. That's why I suggest always starting with drawing the north and having this in mind for bearing. If you have this in mind for bearing, you're going to be able to solve it easily. There are the 5 meters moving in a bearing of 255 degrees. Here is the 255 degrees. All right, and if we keep going for number 3, I already talked about it earlier, but here's trapezoidal rule. Then we have the exact value. See? And almost always I've seen lately, trapezoidal rule is for the approx, integral is for the exact, and they request a percentage error from there. Trapezoidal for approximate, integral for exact. For number 4 here we have normal distribution. The moment you talk about normal distribution, you should already be thinking about normal, CDF, and PDF. So learning these well will help you solve normal distribution easily. Look, even with what I just told you, that inverse normal is give area, get x, while the CDF is give interval and of x's and get an area. Here you can see less than 160, so that is give an x, get up an area, which is the same as probability, so I guess I should mention that area is probability in this context. Immediately, okay, so this is normal CDF. Look at that, this is another interval, normal CDF. Oh, look at this. They gave me a probability. That means they gave me an area. Inverse normal. That is what I'm talking about. Have very clear what your tools do. You're going to be much quicker. Statistical test, well, that is a little tougher, but I stick with the tip I gave you earlier about the null and the alternative hypotheses. The main thing is, here it even says goodness of fit. So there's 2 chi-squareds. You should be going to your calculator, seeing which one you do. Open it up in your calculator, see what it asks for. Work from there. Blah, blah, blah. Same thing here. Not much to say. Oh, well, t-test, didn't mention it earlier, but the idea is the same. T-test, you should be opening up your calculator and seeing where it is. Okay, so even following this example, I can go to stat, test, then find my t-test, and here I can see, oh, there's a single t-test and then a 2-sample t-test. How many samples you have here? Latvian woman and Dutch woman. That's 2 samples, 2-sample t-test. What does it ask for? List 1, list 2. Here it asks for your null hypotheses, and pooled, I should have mentioned this earlier, so I'm going to write it down now. For the statistical tests for IBA ISL, pooled will always be yes. Always. Don't ask why. I mean, well, you can. Basically, it's an assumption of variances between the distributions. For your effects and purposes, just leave pooled as yes. Last but not least, for number 5, just reading it quickly, we have length of the top edge of the skip, height of this. Oh, this is for volumes. So skip. You don't have a formula for volume of a skip. What is a skip? Here's the skip. So what you can do from here is establish maybe that this is a sort of cuboid right there. So there you have a cuboid, okay? And then you have a little bit of a section that's like a triangle. So maybe what you can do is actually find the volume of the entire thing and then just subtract the missing piece. Or not, or maybe there's another approach. But having that stuff in mind, okay, on how to do it is essential. Okay? So again, this is more of a volumes problem. You have to have an eye with geometry and stuff like that. You can train the eye. I have a couple of videos showing a lot of these exercises. Not too much the formal booklet can help you here, besides, you know, establishing that this is a cuboid in a way, or part of it is a cuboid, and then knowing that a cuboid can be something like this, etc., etc. What's the tip I can give you here is that because it does show that, you can take this as true. Interesting. Alright, you guys. So, number 5 is a little bit different. There wasn't too much that the formal booklet could help me with. And I know there's going to be haters in the comments saying, oh yeah, your method was pretty good, but number 5, like, your method didn't help at all. Well, how much did it help with number 4? How much did it help with number 3? How much did it help with number 2? How much did it help with number 1? Guys, this method, for me, it's not a method about getting 100% in the test. It's a method for maximizing your points. And you're going to notice that a lot of what you need to know is in the formal booklet. A lot of what you need to know is about how to manage the calculator. It's about knowing the tools you have. It's about knowing which calculators you have. And going for method points for the average IBA ISL person, going for method points and then getting a couple of answer points correct is more than enough. You probably just need like a 5 or something, you know, and method points assure you the 4. You're gonna get a couple answers right, you will get the 5. That is my approach. That is my method. And the last parting message that I can give you from here. The last parting message that I can give you from here is that you probably feel like this. So you, shortly before the exam, have your helmet. You're surprised, a little bit sweaty, a little bit scared, with your boots and your shotgun. And if you've ever played old school RuneScape, in old school RuneScape, when you try to reach the town of Varrock, there are around 11 dark mages between the levels level 7 or level 20. So some of them hit you pretty hard when you're a noob, okay? This is your IBA ISL paper 1, paper 2. And I hope you take this as a little bit of an inspiration. My metaphor is that when you're a noob that goes to Varrock, these mages always hit you. You know? You can't get in there without getting hit by a fireball, a water bolt, or this or that. And so, it's like this constant thing that every time you go, it hits you. And I know that some of you out there feel this way about math. You just spent 2 years, you know, studying this thing. You just spent 2 years in and out of math classes, maybe in and out of tutors, and you've even started Googling for help, and thankfully you found me, and here I am talking to you, you know? And so you've spent this whole time with these dark mages throwing firebolts at you, throwing water bolts at you, and you take these math exams with your teacher. Sometimes you do well, sometimes you don't do so well. You take these mocks, sometimes you do well, sometimes you don't. Trigonometry, you still don't get it. Circles are weird. Logarithms, variables and exponents, statistical tests, blah 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 blah, and a bunch of stuff. And it just feels like every time you take this math exam, like every time you go to Varrock, something about it is attacking you. It's not helping you fulfill yourself. It's not, something is bothering you. But at this point, especially if you're watching this video, probably this is you before the exam. And I need you to realize something. First off, you are more prepared than what you think. You got your helmet, you got your boots, and in a way, you've already faced this. You've done math exams, you've done math quizzes, you've done homework, you've done mocks. In a way, you've already faced it. Sometimes it felt like a level 7, sometimes it felt like a level 20, but you've already faced it. You're just about to face it one more time. It's just a paper. It's just a piece of paper. And so by now, you're more prepared than what you think. You've stayed up studying. You've learned the different methods and formulas. You've practiced with the formula booklet. You learned the graphing calculator thoroughly. Yet still, even with a shotgun in hand, you're still scared, you're still nervous, and you're still a little bit surprised. And that's gonna happen, okay? I'ma be real with you, okay? When you face the IB, it's not that suddenly, after all this studying, you feel absolutely calm. I know very few people that had that experience. Most, if not all, will still be surprised about what shows up. Will still be kind of scared. Will still be a little bit spooked. But they still face it. They still walk in. They still have the helmet, they still have the boots, they still have the shotgun, and it's very important for you to understand that even though you were scared, even though you were tired, even though you were stressed, you're gonna go in there and you're gonna shoot that shotgun and you're gonna take down that wizard. In other words, you are scared about this IB exam. You don't know about the future. You have questions about this, that, etc. But you're gonna get in there and you're gonna give it all you got. Because right now is not the moment to be thinking, oh, I could have studied more, I could have done this, I could have done that. Nuh-uh. This is the moment where you stand up and say, I have spent so much time studying. I have spent so much effort understanding trigonometry. I have spent hours and hours of sleep not getting and studied being studied, that now you deserve the moment to prove yourself. And you're still going to be surprised. You're still going to be a little bit scared. But you're still walking in there. You're still walking in there. And there's nothing that can stop that. So let's get it. Let's solve this. Give it all you got, because you deserve this moment to prove yourself, and might as well do it. There's no avoiding it. There's no avoiding it. So trust yourself. You know more than what you think you do. You're more prepared than what you think you do. And you're probably going to do better than what you think. See? Now is the moment to trust yourself and take that shotgun and shoot. You might be scared. You might be sleepy. You might, whatever. But you're going to do it. Because you've here and you've made it this far and you earned the ticket to do what you gotta do. So ladies and gentlemen, the mere fact that you clicked on this video and watched part of it, if not all of it, is evidence that you are adding equipment to yourself. You're adding tools. You're adding things to beat this big boss. Okay? And the cool thing about this is that when you play old school RuneScape and you go to the Varrock when you're starting off and these dark wizards attack you a lot, later on you come back and you're super strong and you realize, wow, I could have beat these guys a long time ago. And hopefully that happens to you, because you have put in the work. So my main message is that you are stronger than you believe, you're smarter than what you think, and you are braver than what you suspect, because you're going in there and you're going to whoop ass on this exam. Ladies and gentlemen, I believe in every single one of you, and I would also like to thank you for your constant support with this channel. It has grown in ways that I never imagined. I hope this video helped. It was quite an adventure to do, and remember, I will be downloading all these PDFs and popping them into the Discord. So, the Quiroz math approach. Identify the key concepts and buzzwords. Attack the right procedure or formula. Do what you gotta do to get the procedure or formula. Go ahead and solve. What's the weird, awfully specific stuff you should keep in mind that shows up once per test? Area of triangle, being forced to use the trig version, the bearing, and the idea of the normal. Ladies and gentlemen, that is for the IBA ISL Guide of 2025, and I hope it helped. Take it easy.